for topic 3.2, second part of the chapter 3 is binomial expansion. It's talking about how you expand things. So let's say if you have power of 0, a plus b 0, when we expand it, power of 0 always get back 1. So if you have power of 1, means a plus b, nothing to expand. If you have square, we'll use a square, 2ab, and b squared. So how about power 3? So power 3, we usually use a plus b. Power 3 means we will going to multiply 3 times. Since a plus b squared, you already have the expansion, a squared plus 2ab plus b squared. So if you want to expand for power 3, then we will multiply it one by one. So it will become a power 3, then a square b. Then for the second item here, 2a square b plus 2ab square, and then continue expand for this third, ab square plus b cubed. And we notice that we can simplify a square b, and another part will be 2ab square, ab square. So finally, our expansion will become a to a power of 3. So a square b got 3a square b, and then for ab square also 3, and lastly b cubed. So how about you want to expand power of 5? So you are going to expand and expand. So that is like very trouble. You want to expand one by one like this. So for this topic, binomial expansion, we are talking how we going to expand two terms. What's binomial here means we have two terms here. This is the front term A and the back term B. So two term binomial, dua benda, and expand to a 1 power. So we have two types here. First, for the first type, where our power here, so n greater than 0 means when we see our power here, it is a positive integers, like just now. It's a positive integers. What's mean by positive integers? 1, 2, 3, 5, 6, 10. No more bulat, positive. If our power is positive integers, we can expand using this formula. Okay, so we can look back how we use this formula. So like just now, I already show you how to expand a plus b cubed. Okay, so n0 means 3c0. And then a to the power of n, what's your n? N is 3. And then b0 plus, here will be 3, 1. And then start looking at your expansion. You will notice that your item A power decreasing, your item B power increasing. So for second term here, A will become 3 minus 1 power of 2, then automatic B power of 1. So you can see 3 minus 1 equals to 2, and then 1 take out for the power for B. Continue for here, 3, 2, A, 3 minus 2, 1, and then B power 2, then 3, 3, then A power 0, B power 3, so that's all. So we will expand until and n. So if you have power 4 means 4, 4, power 6, 6, 6, power 10, 10, 10, okay? So this formula only applicable for positive integers. So the power other than positive integers, we will use formula type 2. So continue with here. So what is this? Bracket 3, 0. This is your concept of 3C0 combination and permutation that you last time you learned 3P0, 3C0. So you press your calculator 3C0. It will equals to 1, correct? So this coefficient here is 1. So it becomes A, Q, and B0 is also 1. Plus here 3C1. So you see this is 3 A square B. For this one, also 3C2, also 3. And then 3C3, 1. So notice that our expansion here, and just now we expand manually one by one, they are same. Alright, so means that if I want to find this power 5, I can use this formula instead of going to bracket and open one bracket by one bracket. So it will take a long time. So remember this formula. So in this binomial expansion, the first formula that you're going to use is this. Only applicable for positive integers. So remember, don't use your formula wrongly. If you use your formula wrongly, then everything will go 0. Okay, so what is the relationship between this binomial expansion and our 3.1 series? So you'll notice that after we expand, we can see this actually is our first term. This is our second term. This is our third term. And this is our fourth term. So it is under sequence and series. So plus means it's a series. Okay, but it just don't have geometry or arithmetic properties. It's a pattern of numbers. So we can go for another example. We can see for 2x minus y power to 4. For here, our power is 4. So this is that one. And then you can see what's your a. What's the first term here? So your a will be 2x. Then your b will be negative y. So that is the difference between a, b, and 2x minus y. The things other than 2a, the things other than a and b, you can identify a is what, b is what. So when we expand this thing, we're using formula 2x minus y power of 4. So our formula will start with n0, 4, 0. For a, 2x, power to n, that is 4. For b, negative y, power to 0. Okay? Substitute what's your a, what's your b. Then we move on to the second term, 4, 1. For the front, 2x. Then 4 minus 1, 3. For the back, negative y. Take back power of 1. Plus, continue for 2. And then 2x power 2. Then negative y power 2. Plus, for 3, 2x power 1, and then negative y power 3, and lastly for 4. So this is what we mean here. And means this is the last already. Power 0, and then negative y power 4. So how we simplify it? So press this one. So when you press this one, you find this is how we simplify the first term. This is 4C0 times 2 to the power of 4, and then this one negative 1 power of 0, then is okay, this is 1. So take all your value first. This is value, this is value, this is value. Your unknown is x and y. So take all your values and then you press 4C0 times 2 to the power of 4, and then your coefficient is equals to 16. So we continue with the unknown here. Unknown will be x to the power of 4. And then y power 0 is 1. So this is my first term. Okay, then continue for second term here. Here, what we're going to type here will be 4C1. And then you can see value 2 power of 3. And then times negative 1 power of 1. So you can get your coefficient here, negative 32 x to the power of 3 and y. Okay, so continue here. This is 4c2, and then you see the coefficient value. We have got 2 power of 2, then negative 1 power of 2. So we press your calculator. It becomes value of 24. So this is value of 24 for x to the power of 2, y of power of 2 also. Continue for this 4c3 times 2 to the power of 1 and times negative. So this is a negative 8. X power 1, y power 3. Then last term 4c4, then 2 to the power of 0, and then negative 1 power of 4. So lastly here we'll add y power to 4. Okay, so with this expansion, what is coefficient of x squared? So you find what's x squared. X squared is this. So what is coefficient means what is perkali dia? Perkali dia adalah 24 y power of 2. So for this expansion, again, I can remind you this is our first term, this is our second term, this is our third term, and this is our fourth term, and this is our fifth term. For coefficient of x power 4, what is x power 4? Here. Here is my x power 4. So coefficient perkali dia adalah 16. So what is the coefficient of x cubed y? Then you have to find x cubed y is here. So the coefficient will be equals to negative 32. You can notice that from this expansion, I can find certain term. So when I want to find certain term, I can use this formula TR plus 1 N R and then A minus R BR. So why this one is, here is R, but here is R plus 1. You see here. When you at first term, your R is 0. When you have first term, your R is 0. When you have second term, your R is 1. And then when you have third term, your R is 2. And continue. When you have fourth term, your R is 3. So your term and your R value will be different by 1. So when you have like fourth term, here is 3. I want to find fourth term. So means I'm going to use my power is 4. When this is R plus 1 equals to 4, here R is 3. So my A is 2x. And then my B is negative y. Then 4 minus 3, 1. And then this one negative y power 3. So you can see, is it? Term number 4. So it is 4, 3, 2x1, negative y, 3. So they are same. So this is how we find the second term. You don't need to expand every term. So when the question asks you to find certain term, we can directly use the formula. So you must know what is your R plus 1 and what's your R. Okay, so for what is mean by independent term and constant term is mean by x power to 0. So this one you can see your example in your nota kuliah. So for my expansion here, for this expansion here, I don't have independent term or constant term because I don't have an x power to 0. Doesn't mean like this. This is not independent. Constant term means the whole expansion is just a value only. The whole expansion, the term is value only. So that is called independent term and constant term. Okay, so we move on to type 2 where the power is not positive integers. When your power is not positive integers, your expansion here must start with 1. The question given here must start with 1, so this is anything. But expansion must start with 1. This is for the power that is not positive integers. So your expansion will be 1 plus n is your power, times this diamond, and then n minus 1 over 2 factorial, and then the diamond square, and then n minus 1, n minus 2, 3 factorial. You can see the pattern. When there is n, we divide by 1. When n minus 1, this is 2 factorial. For this one, n minus 1, n minus 3, so 2. So there is 3 things here over 3 factorial. Of course, the diamond things also power of 3. For this expansion, it will be endless. So normally, the question will ask you to expand up to power of 3. So means it will be here. Up to power of 3 means you will expand until here. If the question said expand the first 2 term, then it will be different because this is my first term, this is my second term. So I will expand until here. If we say expand the first three terms. So first term, second term, this is the third term. So we will expand until here only. So you have to see whether you want to expand up to the power or followed by terms. Okay, so for this question, they will check you on validity. When your expansion here, your star here must be less than 1, and then solve what's the value of x that is suitable to use for this expansion. So when you want to open this modulus, this is simple modulus like chapter 2 that day, so you can less than 1 and then more than negative 1. So example, first, when you do your expansion, first, see your power first. This is type 2, where your power is not a positive integers. When you're using type 2, another things you need to check here is always start with 1. So this is my thing, my star, my diamond there. So from here, we identify our power is 1 over 2. Then the diamond things, or I use star, will be negative 2x. So expand the following up to x power of 3 and find its validity. So we expand this up to power of 3. So what is the formula? And then this is your formula, so you have to memorize it. So in this binomial expansion, it got two formula only. One is positive integers one, power positive integers. Another will be power where it is not positive integers. So using that formula, expand, it will start with 1 plus n is 1 over 2. Then your diamond thing, your star thing is negative 2x plus continue n 1 over 2, n minus 1, 1 over 2 minus 1 divided by 2 factorial. And then negative 2x power 2 plus n, n minus 1 and n minus 2 over 3 factorial, then times your star there, power of 3, and let's put 3 dot here. So I will show until up to the power of x power 3. So how you going to simplify this expansion? Just press your calculator only. Press your calculator, 1 over 2 times negative 2. It will give you negative x. Thus, how you press for this? Press your calculator. 1 over 2. 1 over 2 minus 1 over 2 factorial. And then don't forget here, times negative 2 squared. This is your value. So press this value to find it. You press your fraction button first. And then at here, you press again your fraction. And then you put in your 1 over 2. So they will give you answer negative 1 over 2. So for the x is square. Continue for this part. Same also, press your calculator for 1 over 2 times 1 over 2 minus 1, 1 over 2 minus 2, and then 3 factorial, and then don't forget the value here, negative 2 to the power of 3. So x, we no need to press because your calculator cannot press value x. Press your value only. Okay, so continue here for validity, modulus negative 2x less than 1, negative 1. Just use basic definition to define your modulus less than. This is the simple x, just less than negative 1. So now I want to simplify this negative 2. Divide by negative 2, it will become 1 over 2, change sign. And you need to rearrange this thing, where the smaller value at the left hand side follow x, and then this symbol follow 1 over 2. So this is my validity. When we want to substitute the value of x to the expansion, it must in between these two. It must between negative 0 until negative 0.5 until 0.5. So for question B, power not positive integers. And then, so this is type 2. And then this is not 1. So you must make sure this thing is this is value 1. Then only your expansion is correct. So how do I get this? First term here is 1. The first thing here is 1. So we will factorize 2. When you factorize 2, so this 2 is coming from the bracket, so it will power to negative 1. So when you factorize 2, here will become 1. And then you factorize 2, this one will become negative x over 2. So now we only can expand for this. So this is the expansion we can do for here. So for this 2 power of -1, it will be the value of 1 over 2. So for this part, we expand. So our n here is -1. Our expansion here will be -x over 2 plus n star and then plus n minus 1 over 2 factorial. Then this one square and n minus 1 minus 2 3 factorial power of 3 endless and then close back the bracket. Close back the bracket because we have a coefficient 1 over 2 in the front there. So just maintain it. Then we simplify inside here. 1 here will be positive x over 2 and then simplify this. So when you want to simplify this, -1, press your calculator, -2 over 2 factorial. And then this one, you see you got a coefficient, means this is -1 over 2. So you press your calculator for all the value except for x. So you finish your expansion, and then don't forget this one, 1 over 2. Multiply in your 1 over 2 for the first term, second term, third term, and fourth term. So it will become 1 over 2 plus x over 4 So you can see where the question start with 1 and then where the question start with not 1. This is how you simplify. Okay, then we continue for validity. Validity will follow our expansion. This is the expand for -x over 2. So our validity will become modulus -x over 2 less than 1. So how to solve this? We can separate it. This one, negative modulus always become positive. So we can just leave it modulus x over modulus 2. Then modulus x over 2. Then modulus x less than 2. X less than 2. Define your modulus. Open your modulus less than 2 more than -2. So for this part, actually also we can use the properties of your modulus. Modulus -2x less than 1. So it will become modulus -2 modulus x less than 1. So this is value of 2 modulus x less than 1. So x will be modulus less than 1 over 2. Then just open your modulus. So it is same.